And it is at this time every week we bring you our segment Beyond the Sun. Harrison is here, and Jesse, welcome back.
Thank you very much.
Good to have you.
Yeah,
now,
good to be back.
We're going to make a comet.
That's right. We got all the ingredients here to make a comet, and we're going to talk about comets for a lot of today. So that's why we're sort of going over what the ingredients are of a comet. And so the first thing we got here. Well, first of all, if you're going to do a science experiment, you got to be safe.
Yeah.
So I got my.
Oh, I see. Where are our glasses?
Well, I'm doing the science.
You're just the one being safe.
Yeah. As long as I'm safe.
Okay.
Got myself some gloves here, and the reason I got the gloves here, some warm gloves, some thermal gloves, is because we have some dry ice. So this is frozen carbon dioxide.
Okay.
The same stuff you breathe out, it's frozen. It's minus 90 degrees Celsius. Very, very cold.
Oh, neat.
Yeah, there you go.
That's very neat.
And a comet is cold. A comet originates really, really far out in the solar system. So this is going to be our cold, and it's also going to represent some of the ingredients that are there, because on comets you have these volatile chemicals, and we'll get to some of those there. We have chunks of dry ice. So these are the chunks there, and we used a hammer. And we just smashed them up into this little powder that we have here. So I'm just going to add this powder into our bowl here.
Okay.
So that's going to be our cold. I have that stuff left
over.
over.
Like a Halloween mix going on.
Kind of a little bit, yeah. Now, the cool thing about comets is that there's a lot of different ingredients. There's cold, they're really far away, but there's also carbon dioxide on comets, CO2. They have a little bit of rocks. They're typically called dirty snowballs. So if Harrison, you want to add some of this stuff in here. So we got some
snowballs.
It's a nickname. It's not exactly accurate, but it's a comet you could call a dirty snowball.
It's not just dirt?
This is actually from my garden at home.
Okay.
But is coincidentally a lot like what the dirty part of comets is made of.
Just dirt.
So you can kind of think of them as sort of like half rocks and half ices.
Okay.
And one of the ices is carbon dioxide on a typical comet.
Which is what we're using.
Yeah, it's the plural of ice, not ISIS.
Yes.
Very different.
Although we wouldn't mind them on a comet. Okay.
Also, but one of the really cool things about comets is that they come with organic materials on them. And what I mean is carbon-based organic materials, CHs. So we have a little bit of...
If you remember your periodic table, carbon is the letter C, and H is hydrogen. So things that are based on carbon and hydrogen are called organic chemicals.
Okay. And so you're using...
This is corn syrup.
Corn syrup.
So we're going to just add a little corn syrup. That's going to represent the organic materials that come on comets, that you'll find on comets.
Well, there isn't corn syrup on a comet, but how close would that be to representing it?
It's just a placeholder here.
Okay.
It's just going to be carbon and hydrogen that you're going to find there.
All right.
Yeah. And this is another one of the ices you would find. This is just window cleaner. But in window cleaner, you'll find a chemical called ammonia.
Yeah.
And as a cleaner, and that's an ice that you would find on a comet. So
because ammonia is an element that's out there in the solar system in
It's
space.
frozen.
And in comets it can be frozen. Yeah. And here it's a liquid, but that's because it's not minus 200 where we are right now. Happily.
So we're going to add
that. Is it minus 200 in that pot there?
Not 200.
Carbon dioxide, when it's frozen as dry ice, is about minus 90 or so. Minus 90. And now the last ingredient, and this is the big one, this is important, is water. So the last ice we're going to add this in here, and what I'm going to do...
Because you guys often blow things up.
This is going to be rather voluminous, but this is the last ingredient, and I'm going to crush it together using gravity into a sphere. So Harrison, you can go ahead and add that in there.
Yep, and we're just using this bag to keep things contained a little bit. So
this is just water.
This is just water.
And I'm just going to stir it up a little bit.
There's lots of water in space. Water is actually a very common element that's out there in the universe. There's moons around Saturn and Jupiter that are mostly water, ice water.
Okay.
And so it is something that's out there, certainly, and it's actually a big part of comets is frozen ice water. And of course, the Earth is getting water all the time from space because little meteorites and that hit the Earth regularly, and they're often made of ice. And the last ingredient that Jesse's working on right now is actually an important ingredient. It's called gravity. And so what he's doing by forcing all this together is simulating millions and billions of years of gravitational attraction out there in space, where all these ingredients that we've just put in here are being pulled together.
Now, there's a lot of noise. Is that from you squeezing exclusively, or is there actually a chemical reaction going on in there?
We're creating a lot of pressure here now. Where's my...
Okay.
There we go. So
Did you lose the comet?
So this is a nice representation. This is a really real representation of what a comet would be made of. It's mostly rock and ice, so it's dark, it's got ices, and when it's warm, it does this outgassing, and that's what you're talking about, that sound. This outgassing that you're seeing, and you can see it if you look nice and close, or if I blow on it, you can see as I blow on it, the the carbon dioxide that's in there is turning into a gas. And when a comet gets close to the sun, this starts happening, and we see that as a tail. And we see cometary tails. Those are one of the things we've seen throughout history.
Like when Halley's Comet goes by.
Exactly.
That's what you're seeing.
Yeah, when a comet is far from the sun and it's very, very cold, the outgassing isn't happening. But as it gets closer and closer and closer in, that gassing happens and you get
So
tails.
it's slowly disintegrating then?
Absolutely. In fact, most comets that come inside to the inner solar system actually disintegrate.
And you can think of it almost like as evaporating or sublimating as much as disintegrating.
What's the difference between sublimating and...
Great question. So this is all about phase transitions. To go from a solid to a liquid, we call that melting.
Yes.
But to go from solid to a gas, we call that sublimating. So it doesn't go through that middle
Straight
transition.
from solid to gas.
And that's what's happening right now.
Yeah, like these ones here.
Yeah.
This in this little bowl here, this is all solid carbon dioxide. It's frozen solid carbon dioxide.
And it's leaving no liquid behind.
There's no liquid. It's totally dry in here. But if I blow on it, you get this steam, the gas. And so that's gaseous carbon dioxide. It's going directly from a solid to a gas. That's sublimating. For comets, if enough of it sublimates, breaks down, then it will start to disintegrate. But it's that the parts that make up the comet sort of melt as it gets close to the sun, and that is what then allows it to break up.
All right, so then when we come back, we're going to launch this thing into space, or we're just going to talk about comets?
We're gonna talk
It's
about
in
it.
space already. There's a probe for the first time that's going to land on something like this on a Wednesday next week. Quite a historic moment coming up.
All right, we'll talk about that coming up on Beyond the Sun. Stay with us on Straight Talk. Harrison and Jesse are here for Beyond the Sun. Sorry if you just joined us, you missed the formation of a new comet. Did we name it?
Well, I think this is
Cometary?
Agar's comet.
Jessison, or heresy, or something. Well, not heresy, that's not a good one.
Agar's comet.
All right, what kind of witch's brew you got going on there?
Well, we're working with carbon dioxide. We actually had just a little bit of the carbon dioxide left, so I dropped one of the pellets in this. This is just water, and now so the carbon dioxide sort of is boiling off. So
People do this at Halloween. They put
I want to give a disclaimer though on that, because carbon dioxide is not something that you should be playing with. So if anybody can buy it, frozen carbon dioxide, but you should take precautions when you're using it, and only adults should be using it.
because you can at minus 80, you can burn yourself if you touch it without protection.
Yeah.
That's why Jesse's
It's
wearing
cute
gloves.
at Halloween to have the green liquid and the bubbling
Yeah,
kind of
it's-
stuff.
And this is how they do it.
But don't just be giving it to little kids, is what
Exactly.
you're saying.
Definitely.
Okay.
Definitely not.
All right, so we made a comment today. More correctly, you guys made a comment today because there's a big event going on within the week.
The European Space Agency's spacecraft called Rosetta. This is a huge deal. Earlier this year, got into orbit around a comet, 67P Churyumov-Gerasimenko. If you can, that's a mouthful.
Congratulations.
But this is a comet that is coming towards the inner solar system, and they rendezvoused with it. They're orbiting it now, and for the first time, so that's a first, orbiting a comet.
Okay.
And for the first time, on November 12th, they're actually going to put a lander on a comet.
Let me ask you a question first. Does a body not have to be a certain size before you can orbit it?
That was actually one
Good
of the
question.
big challenges with this comet 67P is that it is so small. It's only about 4 kilometers wide. It does have gravity. Everything has gravity, but it's so small that its gravitational pull is actually several 100,000 times weaker than Earth.
Yeah.
So to get something in orbit around that is very tenuous. You have to be very delicate in how you do it. And of course, the spacecraft doing it has to be quite light as well, because the spacecraft has its own gravity.
Sure.
And so it's quite interesting. And actually, as you can see here in the video, that's the Philae lander, the part of Rosetta that's actually going to touch down on the comet on Wednesday. And when it gets close, it's going to touch down. It's got these big screws on its feet. And then it also has harpoons that it's going to shoot into the comet so that when it lands, it doesn't just rebound off the surface because the gravity is so weak.
4 billion miles, and we can control this thing that well.
But we're not. We're
Or is it
semi.
controlling itself?
It is controlling
It's got a
itself
little autonomy,
because it's about 500 million kilometers line of sight, direct line from Earth today, and so that time delay there is about 18 minutes. Excuse me, about 14 minutes. So we couldn't be controlling it because the round trip then would be almost half an hour for when a radio signal from it would get to us and we'd send something back. We couldn't control it ourselves.
All right. Beyond just the fact that we can do this, and it's amazing, and it's a good warning to other life forms out there that we're pretty smart here on Earth.
We are.
What's the practical purpose of it?
The wonderful thing about comets is that, and this is actually the same as asteroids as well, is they are literally pieces of the solar system that never got pulled down onto a planet. So they haven't been processed. They haven't been to the bottom of a planet and back up. They haven't been turned into magma. This is
No
rock.
weather.
no weathering. This is straight up chunks of the solar system that are left over from when the solar system formed. And so understanding the materials that are there, the amounts of materials, the chemical makeup, the amount of abundances, all of these different things tells us a lot about our past.
Because these are time capsules from when the solar system formed 4.5 billion years ago. They've been out in deep space. They haven't been touched. And so if we can start to understand these objects, then we can start to understand how the Earth formed and solar systems formed in general.
Now, this is not going to come back. This machine is not coming back.
this
Well,
not
it's sort of going to in a way. It's the
short
comet-
answer is no. The longer, fun answer is well, sort of.
It's going to go around the sun. So it's way out past Mars right now, and it's on its way in with the comet. The comet is coming towards the sun, and it's going to do a loop around the sun. So it is going to get closer to us.
But it's not going to lift off the comet and
We're
come
not getting
home.
it back.
There's no sample return. Actually, the really neat thing with this one, we were talking about when we were making the comet, is as comets get closer to the sun, they get heat up and they start off-gassing, sort of like is happening in our bubble, toil and trouble here.
Yeah.
The orbiter, Rosetta, and the lander Philae are going to be with the comet and on the comet as it gets closer to the sun and it starts off-gassing. And so I think that's going to be quite remarkable to see how the comet actually changes firsthand, well, through robots firsthand, what's happening as it gets closer to the sun.
Well, how big is this thing? I mean, it must have all kinds of machinery on it to test soil, to test all these conditions you're talking about.
Yeah, Philae, the lander that you're seeing right now, that has 10 different instruments on it, 10 different scientific instruments. But it's not a very big craft.
No, its main body
yeah.
is sort of like a large microwave or like a
it's smaller
kitchen
than this
oven.
table.
Yeah, no,
Oh, yeah.
it's quite small because it has to be. If it were this big and this heavy, you couldn't land something that heavy on something with such low gravity.
The fun thing about its landing, this is really, I just found this out recently, is that it's like if you're going to land on Mars, you got to bring parachutes and you got to bring retro rockets and you got to slow yourself down. This thing is going to be landed simply by dropping it. Because the pull is so gentle, it's literally just going to slowly fall over 7 hours. After they drop it, a 7-hour fall onto the surface. And then
it will
harpoons.
be going at a walking pace when that happens.
Yeah.
Because the gravity is so weak. So the Rosetta
It
orbiter,
can't possibly crash into the comet.
Well, if something goes wrong, it could be at the wrong angle or something like that. But it has thrusters to orient itself correctly. But no, they're mainly just relying on gravity. And as Jesse says, it's just going to float down because the gravity is so weak.
More to come. Stay with us on Straight Talk. Harrison and Jesse are here, an extended version of Beyond the Sun. We're going to take a look back now at a couple of issues we have reported on to an extent. 2 rocket explosions. Let's start, first of all, with one that happily did not hurt any people.
So this was the Orbital Sciences Antares and Cygnus capsule that launched. And there's spectacular videos of this exploding at the Wallops, West Virginia Space Center. It went up, just a few 10 seconds worth of thrust, and then came back down and exploded. And
Here's the
the video.
And it's something actually now as the investigations gotten going underway. One of the things that they think may have happened, we see it takes off sort of normally, and then it was they've done the timing, and it's exactly 15 seconds into the flight. They think, based on the telemetry that they've gotten back, one of the turbo pumps in one of the engines failed, and so the engine lost its thrust. And at that point, the Orbital Sciences controllers realized this launch isn't going to work, and so they hit the detonate button.
Oh, they blew it up.
They blew it up.
As soon as they realize this isn't going to work, they hit the detonate button so that it's as close to the launch pad as possible when it fails. It doesn't veer off course, go somewhere else, hit where people are watching, and so it came straight back down on the pad. Did some damage to the pad, though. A sort of small positive out of this one is that the damage to the pad is not as severe as some people had first thought that it would be. It's something that they expect will be back up and running within a year or so.
So if they had let it go, there's the possibility of it then landing somewhere that could be much more catastrophic.
It's chaotic. It doesn't have any trajectory or thrust at that point, so who knows where it was going to go.
Yeah, and I mean, with losing one of its engines effectively, it probably wouldn't have gone too far, but it may have gone, something could have landed in the water, then you have a much more serious environmental issue to deal with, or it lands where there's people watching 5 miles away.
Well, would it go at a whack? It would veer off?
Well, the thing that broke was, as Harrison mentioned, is this turbo pump, this engine, this thruster. It's actually a Soviet-era thing that used during the Apollo era. Something could have broken. The telemetry, the nozzle that does the directing could have broken. They weren't willing to take any risk. They knew it wasn't going to happen. It wasn't going up.
As soon as they say this thing isn't going to reach orbit, there's no point in delaying it. This isn't going to work. Cut it off.
It's still a fairly courageous instant decision because it's a very, very, very expensive thing.
It is.
All right, now, much different situation than on Halloween morning.
Yes, on October 31st, there was Virgin Galactic doing a test flight of its Spaceship 2. This is the private space plane that's going to take people up to low Earth, excuse me, not low Earth orbit. This is suborbital, so it goes up to about 100 kilometers altitude. One of the test flights, they were testing a new fuel in this one, and unfortunately it broke up, and one of the pilots on board killed, and the second one miraculously survived, traveling at Mach 1 at 50 or 60,000 feet altitude. Fairly remarkable that one was able to survive. He ejected and parachuted down. The preliminary report on this one says that a sort of a feathering system, the Virgin Galactic's space plane's wings, are able to sort of fold back. And that's what allows the spacecraft to re-enter the atmosphere at a safe speed and at a safe, controllable attitude that is, not upside down, not sideways. It keeps it stable in the air. And for reasons unknown at this point, it seems as though that deployed early. And so the spacecraft was unstable, and it sort of tore itself apart as it was lowering in the atmosphere.
Now, this is a Virgin company. There are many of them, but they are all held by Richard Branson. They're private companies, not traded companies, not public companies in any way whatsoever. And one man died. Richard Branson said, worth the risk. How do you react?
Well, so that's an interesting thing here. The point here that his company is doing, and there's other private companies that are doing space
like
research,
SpaceX.
like SpaceX, for instance,
And Orbital Sciences.
and Orbital Sciences. They are a group of people who are interested in where humanity is going next, and they are pushing those frontiers. Now, obviously, none of these people want any of their staff or engineers or researchers to die. They're never going to, and they're going to take every possible way of figuring that out so that nobody gets hurt. But when you're pushing boundaries, even the smartest people on the planet are never going to be able to stop everything from happening. And everybody who's working on these projects knows that. Everybody who's working for these companies knows that. And so it's not like Richard Branson is here saying, I need this done and I'm going to force everybody to do it. That entire company is behind that statement of pushing the boundaries and being those frontier explorers.
And I think it's sort of misleading for people to go out there and suggest that in pushing the frontiers in space travel generally, never mind this new, the private side of it and having ordinary people be able to go to space, just space travel generally is incredibly dangerous. And people have died in it. And I think it's foolhardy to suggest that nobody will ever die in it again. Go back 100 years to the first airplanes. People died all the time in trying to figure out how airplanes work. 100 years later, airplanes still crash sometimes, and people tragically still die sometimes. And yet, we still have airplanes.
And
we still have cars. We still have all these sorts of things.
Nobody's asking the CEOs of the airplane companies, is that worth it to you?
Yeah, well, it sounds cold when he says worth the risk. We have automobiles. People die every day. People are dying right now as we speak. Worth the risk. That is what we as a society are saying.
We are, yes.
Yeah. Thank you very much.
Thanks, sir.
Always good to have you guys. Have a good weekend.
You too.